All right, here we are at number 5, the dreaded fractions problem. So let's go ahead and jump right in and not let these fractions scare us. We're still solving this system by substitution. And so that first question we want to ask ourselves when solving by substitution is one of these equations already solved for x or y? Or is one of these equations easily solvable for x or y? And if we take a look here, neither one of these equations is solved for x or y, and neither one of these is any easier to solve for x or y, so we're just going to have to dive right in. And I personally don't like working with fractions either, but just because we don't like working with fractions doesn't mean we shouldn't know how to deal with fractions. And so let's go ahead and deal with these fractions and clear the fraction from both equations and then start really trying to substitute. And so that would be my recommendation. Let's go ahead and clear our fractions. All right, and we know, let me go ahead and rewrite the first equation here. And equals negative 18, and then we'll write the second equation over here, plus 2 over 9y equals negative 9. All right, so we know that when we're clearing fractions, we have to multiply by the common denominator, and if we're looking at the first equation here, we can see that our common denominator is going to be 6, right, and we can pretend that negative 18 is in fraction form, so negative 18 over 1, just so we can see each denominator. And what number does 2, 3, and 1 all go into evenly? Well, 6, and so that's our common denominator. All right, so let's go ahead and start clearing these fractions. 2 goes into itself once, and 2 goes into 6 3 times, and so we're left with 3x times 3 gives us 9x. And then we have 3 goes into 3 once, 3 goes into 6 twice, and so we're left with negative 1y times 2 gives us negative 2y. And then 1 goes into 1 time, 1 goes into 6 times, so we're now left with negative 18 times 6, which is going to give us negative 108. All right, so now we've rewritten our equation. 3 over 2x minus 1 over 3y equals negative 18 is equivalent to 9x minus 2y equals negative 108, just without the equations. And I think you would agree this would be a lot nicer to work with versus all of these fractions. So let's go ahead and do the same thing here on our equation number 2. And this time, our common denominator, and I'll go ahead and rewrite negative 9 as a fraction, so again, we can see each of our denominators. It's going to be 36, isn't it? Because we're looking for the smallest number that 4, 9, and 1 go into evenly, and so that's going to be 36. But if you're having a hard time figuring out what number that is, in a lot of cases, if you take the two non-1 numbers, because we'll ignore this 1, right? Because 1 will go into any other number, but 4 and 9, there are only certain numbers that each of these will go into evenly. But if you take 4 and multiply it by 9, you get 36, and in a lot of cases, that will end up being your common denominator. Just like here with equation number 1, 2 times 3 gave us our 6, which ended up being the common denominator. Same thing here. 4 times 9 gives us 36, and that ends up being our common denominator. So we're going to multiply each term in the equation by our common denominator and do the same thing. So 4 goes into 4 1 time, 4 goes into 36 9 times, and so we're left with 3x times 9 gives us 27x. And then 9 goes into 9 once, 9 goes into 36 4 times, and so we're left with positive 2y times 4 equals plus 8y. And then 1 goes into 1 time, 1 goes into 36 times, and so we're left with negative 9 times 36 is going to give us a negative 324. All right, and there we have it. We have our second equation now rewritten just without fractions. So again, 27x plus 8y equals negative 324 is equivalent to 3 over 4x plus 2 over 9y equals negative 9. Now we can go ahead and start the process of solving the system by substitution. And again, neither one of these equations is solved for x or y. Neither one is more easily solved for x or y. So I'm going to go ahead and start with our first equation here. And I'm going to I think I'm going to solve for y. So let's go ahead and subtract 9x from both sides. And that's going to leave us with negative 2y equals negative 9x minus 108. And then solving for y, we'll divide by negative 2, divide by negative 2, and that's going to leave us with y equals negative 9 divided by negative 2 is positive 9 over 2x, and then negative 108 divided by negative 2 is a positive 54. All right, so here we have solved for y, and we did end up with another fraction, but that's okay. I think this fraction, when we're dealing with it, it'll either go away likely, or it'll be a fraction that's easy to work with. So let's see what happens with it. But now that we've solved for y with equation number 1, we're going to take this value and plug it into equation 2 where we see that y. All right, so let's rewrite equation 2 now, except we're going to take this y out and plug in the value of y that we just solved for. So we have 27x plus 8. Now we're going to plug in our value for y, which is 9 over 2x plus 54 equals negative 324. And now let's go ahead and clean up the left side, and we're going to go and distribute this positive 8 through. So we get 27x plus, well, we're multiplying 8 times the fraction 9 over 2. And you'll recall that when we multiply fractions, this is really 8 over 1 times 9 over 2. We don't have to worry about common denominators or anything like that when we're multiplying fractions. We just do numerator to numerator, denominator to denominator. And so we have 8 times 9 is going to give us 72 over 1 times 2 is 2. So we get 72 over 2x, but this can be reduced, can it? 72 over 2 is just 36. So we really have 36x. And then 8 times 54 is going to give us a positive 432, and then equals our negative 324. All right, let's go ahead and combine our like terms, and let's go ahead and move this 432 to the other side. So when we add 27x plus 36x, we get 63x. And we've moved our 432 over. And so negative 324 minus 432 is going to give us a negative 756. And lastly, if we're going to solve for x, we'll divide by 63, divide by 63. And so x equals negative 12. All right, so now that we've solved for x is a real number. It's no longer some equation like we have for y. Let's take this value of x, this number, plug it now back into the equation that we solved for y, and find out what y is, right? Because as soon as we take this value of x, plug it in to this equation, we're going to have our y value, and then that'll be our solution. We'll have an x and we'll have a y, and we'll be good to go. So let's go ahead and start evaluating and see what happens. So we have y equals 9 over 2. We're going to plug in this newly found value of x. So plug in that negative 12 plus 54. Well, we have y equals, again, we're multiplying fractions here, right? So we're going to end up with 9 over 2 times negative 12 over 1. So 9 times negative 12 is going to give us negative 108. And then 2 times 1 is going to give us 2. So we end up with negative 108 divided by 2, which is going to give us a negative 54. And then we have plus 54. Well, what does y equal? Well, negative 54 plus 54 gives us a 0, doesn't it? And so y equals 0. And now that we've solved for y, we've solved for x, let's go ahead and put these two values into an ordered pair, right? Because an ordered pair is an x and a y. So we have negative 12 and 0. And there we have the solution to our system solved by substitution. All right, and again, on a test, if you have time, if you finish the test early before you leave, please take every minute that you have available to you. Don't leave early. Take the time and go back, and with a lot of these questions on this test, you're going to be able to go back, plug in the solution that you found, and test to see whether or not you got the right answer. So walking out the door on test day for a majority of these questions, you're going to have a good idea of whether or not you got it right or wrong, because if we take this solution, negative 12, 0, and plug it into each of our original equations, we should get a true statement for each of these equations. If we don't, if we only get a true statement for one or get a true statement for none, then we know that something happened with our algebra, and we've got to really go back and utilize our time wisely and try to figure out what happened, because this solution has to work and make both of these equations true in order to be the solution. And if you don't want to plug this solution back into the original, you can go back and plug this solution into the two equations that we rewrote without fractions. So that would work perfectly fine too. So take this solution and plug it back into each of the two equations without fractions. And again, you should still get true statements for each of these. If you don't, go back and check your algebra. But our solution here with number 5 is negative 12, 0. I'll see you at question number 6.